as a word itself, for those that are English people, what does inverse mean? Opposite. So inverse operations, if I said, what's the inverse operation of multiplication, you would say, perfect. Okay, so awesome that you guys know that. That's the term for that, because not a lot of people do. So a function that interchanges the input value and the output values. So this means that the domain, okay, domain, is that your x values or your y values? X, domain, it's okay. It's been a long break. And our range is our y values. Which one's your input? Is it going to be your x values or your y values? X, good, you're inputting something. Your output is your y. So if I put in 5 for x, you know, I can get 10 back. That's what an output is. You're getting something back. Okay, so if a function is described by an equation in x and y, you can obtain the inverse by the following steps. Hold on, this is coming apart on me. There we go. Okay, you can rewrite the equation, but we need to interchange, which just means switch, if you need to make that note, x and y, or y and x. Okay, so all you're going to do when you're given a function, you need to switch x and y first. Then we're going to solve for y, which some of you sometimes get a little tricked up on that. You think that you need to solve for x always. But in order to find the inverse function, we need to solve for y. Then we're going to replace y with this notation. So I think we kind of went over this a little bit. Does anyone remember what the notation is for inverses? It's okay. I'll tell you. So we're going to replace y with f of negative 1 to the x power. Because that means inverse. Specifically, if you were to actually say this out loud, I'm going to put like little quotes, like if you were to say it in your head, it means f inverse of x. So if I give you an original graph, an original function, in order to find the inverse, we must do all the opposite stuff to find out what that function is. That's just the steps for you to make sure that if you get stuck on something, you can go back and look at it. Now let's actually do a problem. So again, a lot easier than what we have written here. So the first step, we're going to do what? Switch. Yeah, we're going to switch them. Now I don't see y, but what is y? Good, f of x. So I'm going to switch my y and my x value. So if you have a highlighter, if you like highlighters, all I'm going to do is I'm going to switch that y and that x value. So I have x now equals negative 3. Whoopsies. You want to go back to chapter 6, do you? Negative 3y minus 5. Okay, all I did was I switched the x and the y value. Now again, a lot of people for some reason now want to solve for x because that's just what you're used to doing, but we're not. We're solving for y. Okay, that's step 2, but we gave you space so that you can do it. What do I have to do to both sides first in order to solve for y? Add 5 to both sides of the equation. That disappears. I now have x plus 5 equals negative 3y. Now what must I do to both sides of the equation? Good, divide by negative 3. So I am now left with y equals x plus 5 all over negative 3. Now you could rewrite that if you want. You don't have to look more into slope-intercept form, but we can just leave it. That's fine. But I'm going to actually write it out for you just in case you like to do that. Remember that the negative 3 goes to both of them, so technically I would have y equals a negative 1/3 x minus a 5/3. If you were to split it up, don't have to. Some people like to do that because they really like slope-intercept form, because it's easier to graph that in your head than this. My very last step is very simple. There's really no math involved. All you're doing is you're making sure that you're denoting, you're indicating that what you just did is the inverse. In order to do that, you just must replace it with that inverse notation, which is that f of -1 to the x power. And you're just rewriting what you just did. So x plus 5 all over -3. Or you could have rewrote the other one. That's it. Okay? Some of you will be able to skip some steps. Some of you may not be able to do that. It's kind of how your own brain works. Okay? Pretty straightforward. All you're doing is solving. Do you have any questions at this point? That's really all we're doing today. Some practice with it. Okay. So I want you to get out your graphing calculator. If you need one, you know where they are. Give you a minute to get that out. Yeah, it was dead. My hairdresser was not happy with me that it took me 6 months to get in, yeah. You guys are first over my hair and everything, even though I'm getting married, it's okay. Okay, so when you are graphing this, look at your notes first and see what it's asking. The table says f of x. So is that my original or my inverse? Original. So let's plug into the y equals our original graph, our original function, if it'll let me scroll up. Okay, so our original one. You want to go to y equals and type in -3x minus 5. Okay, so go to y equals, type that in. In order to get to table, hopefully you remember how to do that. You press second graph. For those that are having a brain fart, 'cause it's been a very long time, I will walk you through that one. So we have, you go to y equals and you type in -3x minus 5. And then we press second, which is in this red right here, and then graph. And you should get your table. Go ahead and fill that in. Now do the other one. Come on. If you need help, please let us know. Ms. Markowitz will come and help you out with that. For the first one, you should have got 4, 1, 2, -2, -5, -8. Now remember the inverse one. It's the one that you just found. The inverse of our original function is x plus 5 over -3. What did you get for -8? 1. What about -5? 0. What about -2? Anyone else other than Jenna? 1? No one else? You should have gotten -2 and -3. Hopefully you're trying this with me. This is kind of what, the more you participate in class, I'm telling you, the better you understand. Even if it's wrong, yes. You could look off the graph if you'd like. Okay, now let's actually graph these out. So I'm going to graph the first one in one color. I got -3, 1, 2, 3, and I got a 4, 1, 2, 3, 4. Then I have -2, 1. I have -1, -2, 0, -5. And I have 1, -8. So it looks something like that. I like to use my ID to help me draw a straight line. It's not always perfect, but, and I'm actually going to write it out so that I remember that that is f of x. That's my original. Then I'm going to graph the other one and denote that inverse notation as well. So I have -8, 1. Oop, I think it's all the way down. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then I have -5, 0, 1, 2, 3, 4, 5. Something like that in purple. All right. And again, I'm going to write that as f to the negative 1 power x because that tells me in my head that that's the inverse. That does not look pretty. Let me rewrite that. F of negative 1 to the x. There we go. Okay. As you can see here, they intersect at some point. We'll talk a little bit more about their symmetry in a second here. But let's talk about the domain and range of both of these graphs. They're linear. So what is the domain and range of both of them? All real numbers. Very good. So negative infinity to positive. Negative infinity to positive. All of them should be all real numbers because they are linear. Okay? The original and the inverse are all real numbers because they are linear functions. And flip the page when you're ready to move on. I would like you to try 1B because it's the same exact kind of problem, set up the same exact kind of way. I'll give you a couple minutes to work through that with your group. This is for 3 days, these notes, not 1 day. So feel like, yeah, do not feel like you're going through all these. 3 days.
Well, we're still got homework for each of the days, though, correct?
You do get homework for 3 days, but you should go. I'm going to go over that because people are getting stuck on the 1/2. Which is actually very common. Okay, so the very first step, you guys did pretty good. If it helps you, some people need to write all the steps out. And again, it's okay. It depends on who you are. If you need to first replace f of x with y to help you out, that's okay. Because some people cannot see, and again, totally fine, that f of x and y are the same thing. They are, because y is that output value. But then I would switch the x and the y, just the letters. Everything else remains the same. Now, here's where people started getting stuck, is that 1/2 part. The first part was easy. Everyone did that one correctly. And you got x minus 3 equals 1/2 y. Now, the way that I do this, I ask myself, again, the goal is to get y alone. Read it. Read math. I know it's kind of weird to think about. 1 divided by 2. The inverse of dividing is to multiply. Okay, so I'm going to multiply both sides by 2. But remember, when you multiply something that's more than one thing, like this situation here, you have to multiply them both. Yes? You can't divide by 0.5 because this is 0.5. Right? So this is 0.5y. Oh, you could. Yes, you can do that.
We don't really like seeing a fraction within a fraction.
Yeah.
It's really messy. When you guys are looking at that, you're kind of thinking, this doesn't look right.
Yep.
That's why you got to simplify it. And it's always easier when you have a fraction to multiply by the reciprocal, which would be flipping the fraction. So 2 over 1.
Exactly.
Which is just 2.
Exactly. Okay, so you could do the dividing by 0.5, but it would get a little bit messy. Okay, and it is really good for you to know that you need to multiply by the reciprocal, like Ms. Markowitz said. Okay, so we're going to multiply by 2, and guess what happens? Again, they reduce. So if it helps you to if you're just going to multiply by the reciprocal, it would be 2 over 1, if that helps you out. So I am left with 2x minus 6 equals y. Okay, so that's my answer there. And then the last and final step is because we don't know what y is. That's kind of confusing. So when you're comparing two functions, we need to be able to identify that one's the inverse. And the only way to do that is to replace it with that inverse notation. So no math done there. It's just replacing the y with this inverse notation. Otherwise, I don't know if that's the original or what that is. Well, I'm telling you it's the inverse. Okay. Is there any questions about anything that we just did? That's probably the harder of the ones because of that reciprocal. A lot of people get that one wrong. Yes?
Can we just switch as 2 times x minus 3?
You could. We like to have it in intercept form, though. Slope-intercept form. Okay, I know that like last semester we're like, factor everything, leave it in factored form. But this semester, take it chapter by chapter because it's going to be a little different than last semester. A lot of you will like this semester. It's a little bit different. Okay, you guys should have got 2 here, 2.5, 3, 3.5, and 4. You should have got negative 2 here, negative 1, 0, 1, and 2. Okay, hopefully your graphs look what they need to be. It's going to look something like this. I'm not going to graph them completely accurate right now, just for the sake of time. But it should have looked something along those lines. I'm not telling you it's perfectly accurate, but it should have looked something like that. Okay. Now, what is the domain and range of both of those lines again? Good. All real numbers, negative infinity to positive. Make sure that you understand that this means all real numbers on the final exam. I think some people get confused. This is called interval notation. It's in intervals, parentheses. And then if we say all real numbers, you should be able to understand that they're both meaning the same thing. Okay, when you're looking at examples 1A and B, what do you notice about the graphs of the function and its inverse? So when you're looking at the graphs, what do you notice about the original and its inverse? Yes?
They intersect.
They intersect. That's a good one. So they intersect. What else? It's kind of hard to see. Hmm? It does. Well, not always, but in this situation, yes. Do they look symmetric at all? Like they're going to be somehow symmetrical to each other? Does it look like they're symmetrical to each other in some way? Hopefully you're nodding your head yes. So they are symmetric, and we'll talk about that in a second here. What do you notice about the tables of values that represent the function? So look right now at the one that we just did, or the one before that might be even easier to see. Okay, when you look at the original and you look at the inverse, what do you notice about all of the x's and the y's? Yeah, the x and the y switch. Isn't that ironic and a coincidence that in the very beginning we switched the x and y, right? There's a reason, because again, they're inverses of each other. So we have x's and y's. They are called interchanging. They interchange with each other, or they switch if that helps you out. Interchange is more of the fancier word. There is a special relationship between the two. They are symmetric like we talked about, but they're over some line, and that line is going to be y equals x. Inverse operations or inverse functions are going to be symmetric over the line with y equals x. And I can kind of explain that a little bit more in the more accurate one. Okay, if I were to draw my y equals x line in green here, you're going to notice that they're symmetrical. They are symmetric over that line. Okay. Flip it. We're almost done. We got 2 more examples. We're not doing the graph part of the next page. Okay, this is actually probably the easier of the bunch. We're looking at the tables, and we're asking, are they inverses of each other? So when we look at these, do these switch? When I go from f of x to the inverse, yes. Do these ones switch? And these, and these, and these. Do they all switch with each other? Do they all interchange with each other? Yes. So it is y equals x. It is an inverse. Because if all of the x's and all of the y's interchange with each other, they are inverses. Let's look at 2b. Let's look at the first one. Do these perfectly switch with each other? No, look. The 9s do, but don't circle that. I would actually rather you circle the -2 and the -13. They're different. They're not the same. Okay, they didn't switch perfectly, so no, not inverse. Okay. So now the next part is just asking you, how do we make them inverses? Well, I just told you. You switch all of them. So here we go. This becomes 4 and -8. All I'm doing is switching them. And if you need to make that notation or make a note to yourself, you're switching the x and the y's. So this becomes 5. This becomes -4. This becomes 6, 0, 7, 4, 8, and 8. I don't think I need you to do the next one. I think you could get that far. Do you have any questions?